Hello everyone, today I'm going to talk about the significance level. The significance level is the probability of rejecting the null hypothesis when the null hypothesis is true. That we are willing to tolerate. This condition is actually very important. It's not a descriptive probability that we find after getting our data and calculating the statistic. It's a threshold that we are setting up at the beginning of the test. Basically, we are saying that we are willing to tolerate certain level of falsely rejecting the null hypothesis, and that's how we are going to do our decision making in the hypothesis test. So keep this point in mind. So from the z-test, we calculate a metric which is called the z-score. Sometimes it's known as the z statistics, sometimes known as the z standardized statistics. So these are really the same terminology. And basically, in the z-test, this z-score is assumed to have a distribution with a mean of 0 and a standard deviation, which we denote as sigma of 1. We are basically framing the hypothesis test. So this distribution represents the null hypothesis, which we denote as H0. And what is the significance level then? The significance level is the area under which we define the rejection region. So define 1.96 and minus 1.96. So these are called the critical values. We have two of them. And the area outside of this 1.96, it's 5%. So 5% is the sum of this area outside. This is also known as the rejection region. So by making a decision on the significance level, we are defining how big the rejection region is. Let's say if we define the rejection region to be 1%, and you can imagine I'm going to highlight this part with red. So that would correspond to another rejection region that's further out, where the sum of the area under the curve would be 1%. So without running the test at this moment, what does this say? So this is saying that we are going to compute some z-score from our sample. And under the null hypothesis, the z-score can be distributed anywhere from positive infinity to negative infinity. It's going to concentrate a lot around 0. And the further away from 0, the less likely we're going to get a z-score like that. And remember again, the z-score is obtained by running an experiment. So philosophically, if you want to get a lot of z-score, you have to repeat the entire experiment multiple times. So now, let's say you have determined a alpha value to use as your significance level. I'm going to redraw this. So that this area 5%. So alpha equal 5%. And we are going to calculate from our data some z-score. And the formula usually goes by, you take the mean of x, the measurement data, subtracted by the mean that you have in the null hypothesis, and then you divide it by the standard deviation of the mean. So this is sometimes known as the standard error of the sample mean, and it can be calculated by the standard deviation of the population divided by the square root of the sample size. So these are just some detail of how you get the z-score. So let's say in this example, the critical value are still 1.96 and negative 1.96, and we calculated a z-score that is equal to 3. So a z-scores of 3 would lie somewhere around here. The first question you might ask yourself is, how extreme or how likely it is to get a value as extreme as 3? How extreme is the score equal to 3? Well, to get that, you basically look at the probability that the z-score could be less than -3 and greater than 3. If you calculate this probability, it's going to be about 0.27%. So what we are saying is that to get a value of z-score to be 3 or more extreme under the null hypothesis, that probability is only 0.27%. By the way, this is what we call the p-value. This 0.27% p-value is smaller than the 5% threshold, which is the significance level. We will make the decision to reject the null hypothesis. So how does this reasoning work? Basically, what we are saying is that we have a normal distribution here under the null hypothesis that describe our belief of where the z-score should be if we are able to rerun the experiment over and over. And obviously, since it peaks around 0, the further away it is from 0, the more we believe that it's less likely to happen. But also at the same time, in this case, when the z-score we get is quite far away from 0, that it only occurs at 0.27% of the time, another thoughts come to our mind. Maybe the null hypothesis is not true. So that's exactly the statistical thinking in here. That because of the evidence we have on hand, basically we had data and we calculated a z-scores of 3 from our data, and under the null hypothesis, this data is so unlikely to happen. This caused us to think that maybe the null hypothesis is not true. We should reject the null hypothesis. So now coming back to 5%. So this 5% is basically the threshold where we make the decision of rejecting the null hypothesis. So on another hand, let's say if we get a z-score of just say, let's say 1, then you can see that there's a big chunk of probability that represent, there's a big chunk of probability where z-score could be greater than 1 or less than -1. So it's not hard to obtain a z-score as extreme as 1. In that case, we wouldn't reject the null hypothesis. Alright, that's all I have for today. Thank you.